Welcome Wildcats. Today we're going to start looking at section 1.1 in your textbook. Specifically, we're going to be talking about the very beginning of that section. We're going to be looking at the three different ways we have notations. Those three different methods that we use are set, interval, and inequality notations. First though, let's look at some vocabulary. First thing we need to know is what a set is. And in mathematics terms, it's just a collection or a group of things that are all similar. An element is something that fits in a set. We'll talk about that in a minute. A subset is exactly what it sounds like. It's a set within a set. An empty set, again, exactly what it sounds like. It's a set that has nothing in it. Sometimes we call it a null set. So we need to know both terms, empty and null. There are two kinds of sets that we worry about. The first one is one where you have a limited number of elements. So that's things like the numbers 1 to 10. There's only 10 of them. That's a finite set. However, if we wanted to talk about all numbers ever, that's an unlimited number of elements, which would be an infinite set. So, like I said, there's three different notations that we're going to use to talk about these things. The first one is set notation. Now what set notation does is it uses brackets and it lists all the numbers in a set. Now I shouldn't say all the numbers. It lists all of the items in a set. Do note that a set doesn't have to be numbers. An example of that could be that we could be talking about the letters of the alphabet. So in that case, your set would be A, B, C, D, all the way through Z. Now you can also have numbers as your set. Say for example 2, 4, 6, 8, 10. Well, that would be the positive even numbers. So those are two examples of set notation, or more specifically, two examples of when you would use set notation. Let's take a look at the next type though, inequalities. So inequality notation uses our inequality symbols to show relationships. Less than, greater than, less than or equal to, greater than or equal to, and then finally not equal to. So if you wanted all the numbers that are less than 2 or greater than or equal to 5, that's what you would write. X is less than 2 or X is greater than or equal to 5. If you wanted all the numbers between -1 and 2, including -1 but not 2, -1 is less than or equal to X is less than 2. Finally, interval notation. In this case, we use parentheses and brackets to show those exact same relationships we're talking about. So you take the smallest number to the largest number. Now if it includes that number, you use a bracket instead. So if it includes it, it's a bracket. If it doesn't include it, it's an open parenthesis. So the example that we had before was X is less than -2 or greater than or equal to number 5. Well, in interval notation, we'd say the smallest number we can get to is -infinity. Then it goes up to 2. So that would be -infinity to 2. Then on the other half of it, the smallest number we could get to is 5. The biggest number we could get to is infinity. However, it includes 5, but not infinity. And then to show that we're talking about both of these, we put a U between them. So it would look like this. The other example that we had was -1 to 2, including -1 but not 2. And we end up with the same thing. A closed bracket for -1 and an open parentheses for 2. So let's take a look at this table. This table has three different intervals that we're going to talk about. The first one is all the real numbers from A to B, including A and B. So that is a finite interval. You can only have so many numbers between them. As an inequality, we would be looking at a as the smallest is less than x is less than b. However, it says including a and b. So we would need to add our little lines underneath there. That gives us our inequality. Now, something to note with set notation, I've written this a little bit too big, so let me rewrite it a bit smaller. With set notation, all we do is we add x bar before it and we close it in brackets. So it ends up looking like that. The way we read this is all numbers x such that a is less than or equal to x is less than or equal to b. So our set notation is there. Finally, interval notation, even easier. A to b. What's the smallest number? A. What's the biggest number? B. Can it include A? Can it include B? Nice and simple. Now let's look at all real numbers greater than A. Well, we know that the numbers never stop counting as we go bigger and bigger. So that means we have an infinite interval. Now our inequality, we always start with x, and we know that if it's greater than A, we just take that word greater than A. And just like before, our set notation is going to do the exact same thing. We just have our x such that, and then we enclose it in our brackets. So, x such that x is greater than A. So all numbers x where x is bigger than A. Interval notation, once again, the same thing. What's the smallest we can have? A. What's the biggest we can have? Well, it never stops. So it goes up to infinity. Can it include A? Not in this case. Can it include infinity? No, because you can never really get there, right? So you'll find that infinity is always a parenthesis, never a closed bracket. So we have A comma infinity. Now, our last one here is all real numbers less than or equal to A or greater than B. Well, less than or equal to A, so x is less than or equal to A, or x is greater than B. Again, that's infinite because we keep going to the left here, we keep going to the right here, and it looks exactly the same. Once again, if you put the letter x bar and enclose it in brackets, you get your set notation. I want you guys to notice that on all of these. If you know your inequality notation, you know your set notation, because all you have to do is put the x and the vertical line and then put it in brackets. That's all you have to do. That's the only difference. With our interval notation, we're going to have two different intervals, the first half and the second half. At the beginning, we're saying x is less than or equal to A. So what's the smallest x can be? Well, it never stops. It keeps going. So negative infinity. What's the biggest it can be on that first half? Well, it goes up to A. Does it include A? Yes. Does it include infinity? We just said that it never does. So because we're doing two different ones, again, we're going to put the u between them, and then we're going to say what's the smallest that the second half can be? B. And how high does it go? Infinity. Again, we know that it never includes infinity, and in this case we know that it doesn't include B because we've already added that. That's really all there is to the notation styles that we're going to use. So with that, you have all of the information you need to complete the first set of problems within 1.1. I will include in post-production a listing of what those numbers are. They're going to be in the description below.